In last class we discussed about total internal reflection, and I told you that there are some natural phenomenon which are where this total internal reflection principle is observed. One such phenomenon is mirage. So generally we know what is mirage. It is an optical illusion which is produced in deserts, right? So here we consider a distant object. Suppose this is a distant tree, not generally visible by this person. The person cannot see the tree is a distant one, but due to a change in density of the air layer, because it is in deserts, what we know that the lower layer of uh, sand, you can say that the sand is too hot, and as a result the air layer which is in contact with the sand, like this air layer, the lower one, they become hot easily and their density becomes less. Okay, and the upper air layer, their density is more. So we can say that these are dense layer, these are rarer medium, rarer layer. Okay, as a result, when light ray comes from the tree, it goes like this, like this. So when light ray comes from the tree, it is actually moving from denser medium to rarer medium, and we know that if it moves from denser medium to rarer medium, there is a chance of total internal reflection. As a result, if we know that there are two conditions under which total internal reflection can take place. One is when the light ray is moving from denser to rarer medium, just like this, and another case if the angle of incidence is more than critical angle. Suppose, just an example, if this is the normal and this is the angle, in case this angle of incidence becomes more than the critical angle, then what we expect? We expect that the light ray, without going in this way, the light ray will undergo total internal reflection and it will reflect back like this. So once it reflects back, the person, it will fall in the eyes of the person, and the person cannot see the tree, but the person will see in a straight line order, because we know that we can see only in straight line way, not a curved way, right? So the person will see like this, and the image of the tree the person will be able to see somewhere here. So if the person sees an inverted image of a tree somewhere here, certainly the person will think like water is present here, and in that water only he is able to get the image of it. So that is a kind of illusion. The person will feel like, okay, here some water is there, right? But as the person approach near, this illusion will go away, and he will not find any water here actually, right? So this phenomenon, why it is happening? Because of the different density of air layers, right? That is why this uh, phenomenon is happening. So this is about mirage. Now about looming. Okay, just a second. Okay, now this looming, this is also a similar kind of illusion, but this generally is found in cold region, ice covered region. So suppose there is a, in a sea there is a ship, S is the ship. Now in cold region the reverse thing will happen. Reverse thing will happen means the lower layer will be denser, the upper layers will be rarer. Okay, so as a result, when light ray moves from the ship like this, the light is actually going from denser to rarer medium again. So if it is going from denser to rarer medium, because lower layers are denser, I said, upper layers are rarer, so as it is moving from denser to rarer level, there is always a chance of total internal reflection. As a result, the light ray will not go this way, but what will happen? It will come back in following total internal reflection, and this is the eye position of the person, suppose. So as a result, the person cannot see this shape, but the person will see in a straight line way, and he will see that the ship is somewhere suspended in air. Okay, and that is an optical illusion. It is called looming. So why this is happening? This is again due to total internal reflection. Alright, it is not always found, not only not like in cold region always we will find looming. two conditions has to be satisfied. This condition will be satisfied only, that light ray will move from denser medium to rarer medium. Another condition, that the angle of incidence should be greater than the critical angle. So this condition also should be satisfied, then only the person can see looming. Okay, so these are the two phenomenon. Now another thing, this one here also total internal reflection is found. Sparkling of diamond, or we say that brilliance of diamond. Brilliance of diamond means we know that the sparkling of diamond, right? So why a diamond gives us much or very high sparkling? What is the reason behind it? So let us see that. Due to the shape of the diamond, suppose the shape is like this, it is cut in this way, okay, and light ray is allowed to fall like this. This is the light ray. Now what happened is, the refractive index of diamond, it is in the order of 2.4, nearly 2.4, the value of mu. And if you remember, I gave you one formula in total internal reflection, 1 by sine IC is equal to mu. Okay, so if mu for diamond is 2.4, IC we can find out by solving this equation. IC means critical angle for diamond, and it is seen that the critical angle of diamond comes as 24.4 degree. It's a small angle, 24, not even 30, not even 25, okay, 24.4. So for all the light ray falling in diamond, there is a possibility that the angle of incidence will be greater than this, because this value is so small that almost all the light ray will fall in diamond at an angle more than this value. So if it is more than this, we know that there will be total internal reflection. So what happened is, suppose this light ray is coming and falling at this edge of diamond. Now it should go out, right? Because of refraction, it should go something like this, somewhere here. But due to total internal reflection, when it is moving from diamond to air, from denser medium to rarer medium, due to total internal reflection, because this is the normal drawn at the point of incidence. If this is the normal, this should be the angle of incidence, and from the figure only it is clear that this angle of incidence is clearly more than 24.4 degree. So if it is so, the light ray will not go out, but it will be trapped inside. It will undergo total internal reflection and it will go like this. Okay, now again it has a chance to go out of the diamond, but it will not go, because if you draw a normal here like this, this is the angle of incidence, and this angle of incidence is again more than critical angle. So it will follow total internal reflection like this. Now it will go out, because the reason is that this time on this surface, if you draw the normal, the line itself will be the normal. So when all the ray, when it moves along the normal, there is no deviation, we know this one. Okay, so it will go perpendicularly outward. So anyways, see, before it goes away or before it goes out, it suffers a number of total internal reflection. Here I have that means only one light ray is shown here, but there will be a number of light rays, and as all these light rays undergo total internal reflection, the intensity of light inside the diamond will increase, because at a time large intensity of light will be trapped inside the diamond, and once this light ray together comes out, it causes the sparkling of diamond, or it causes the brilliance of diamond. Okay, so for the brilliance of diamond also, which principle is responsible? That is the total internal reflection. So I think now it is clear. So we are done with total internal reflection. In next class we will discuss about refraction at different curved surfaces. Thank you.